So everybody has a rational side, which tends to look at the problems, so thinks generally negatively, and can keep rationalizing forever and not make any decisions. Whereas the emotional elephant is slow to move and hard to control. As you can see, the rider is much smaller compared to the elephant and tends to get discouraged very easily. But once it makes a decision, identifies with something emotionally and starts moving, then it's hard to stop it. It keeps moving. So if you want to communicate anything, then essentially you have to reach both the elephant and the rider. So how is it that the human mind evolved to be like this, to have a split personality? So you have to think of all the communication and the global warming and the engagement we're trying to do in this context, because when you're communicating, like here, I'm here giving you information, I'm not expecting you to change anything. If you learn from it, great. So I'm just giving you information. Whereas you could also be communicating to actually engage people, to go clean the park or reduce pollution somewhere and so on. Or it could be to actually change their norms and behaviors. So you could be communicating for various reasons. And a lot of the global warming communication thus far from scientists has focused on telling the world that the global warming is bad, we are doing something bad, but scientists are not really good at communicating to the human mind. They think if you have information, that should be enough, and you scream at people, you tell them the world is coming to an end, and they'll jump up and start doing something about it. Well, that's not how it works. And you can see that. This is from Jim Hansen, those of you know him. Like Kevin Trenworth, he's one of the most vocal proponents of how bad global warming is. He writes books like this, Storms of My Grandchildren, The Truth About the Coming of Climate Catastrophe and the Last Chance to Save Humanity. As a scientist, even I don't agree with these kind of statements. This is too gloom and doom, too chicken little, right? And there's a new book called Our Dying Planet. Really? The planet will never die. Maybe humans will die, right? Biology will do just fine. So we have to be careful what we are saying. So the communication scientists like Fisher from Carnegie Mellon have been looking at the psychology of communication of global warming, and he says very clearly that people often have flawed intuition regarding how well they communicate, typically exaggerating their success. Right? In ordinary conversation, people receive feedback, but if I'm standing here, you may ask questions, but generally, I don't necessarily get a good feedback about it. So scientists in general are not the best of communicators. And the problem we are dealing with is also pretty complicated. How many of you have seen this curve before? Is there anybody who's never seen this? Is there anybody who's never seen this? Okay. This is called the healing curve, right? Well, you should see it as soon as possible. Right here. So he's been measuring carbon dioxide in Mauna Loa, and it shows the seasonal cycle and the continuous increase. And if you take out the trend, then you will see the El Nino and so on. The trend will very clearly signal. But this is very precise, very accurate, so you can reproduce it. No doubt that it's very accurate. And you have instrumental records. Now this is the global mean temperature. So there is the issue of how well it's covered, how well it represents the global mean, but this is fairly accurate and reproducible. The question is, can this be explained that each year is now having a new record of warm spring or warm winter or warm summer and so on with other extreme events? It's not that easy, especially because to understand this, you need to go through a lot of attribution and eliminate all the other potential causes like natural variability. And that's not always easy. So the attribution science gets very difficult, and especially because you need to know the climate sensitivity. If you increase CO2 by a certain amount, how much does that translate into energy balance and increase in temperature, especially global temperature? And the local temperatures get even more complicated because the temperature doesn't change uniformly everywhere. And this doesn't even matter because nobody lives in global mean temperature. So you then begin to look for longer records of temperature. And this is going back to the beginning of the Industrial Revolution. This is the temperature estimate. So you can see that the uncertainties or the variability begins to increase, and the relation between the CO2 and temperature is not that obvious. So the problem itself is inherently complicated, so normal people don't necessarily perceive the complexity of the problem. You go even longer term using ice core records, which tell you very clearly that CO2 has been varied on some time scales in the past. Methane has been varying and temperature has been varying. I think yesterday, maybe Beth mentioned this. We know that in the past, or maybe Marcus did, temperature has generally led because orbital changes happen, radiation or energy coming in changes, seasonal distribution and so on. That starts the ice albedo feedback. Then you get a response in CO2 and methane. And what we are doing now is reversing the problem. We are increasing CO2 quite rapidly, larger than anything we've seen in the last 20 million years, maybe even 60 million years. And we've increased methane. You have to be careful. The scales here are parts per billion and this parts per million. So the temperature has not increased yet. And this is what is called emitted warming. So even if we stop emitting carbon right there, temperature will eventually reach this relation and then it will jump up because the ocean will start bringing it back and so on. So the essential science we have behind global warming is very solid, but to explain it to people is not that easy. So we have to be really aware of that instead of always screaming. So now you take that climate information and you try to project it on impacts. You want to show people that how climate is impacting biodiversity and so on. So this is from a UN report which says that there are already 350,000 deaths per year that are attributable to climate-related events. If we don't do anything, it could be about 1 million per year in about by 2030, in 20 years. And you have huge losses, and these are mostly in developing countries, and the economic losses and financial losses are mostly the developed world, which is not surprising. But the fingerprinting and other techniques that go into attributing climate change to these kind of things is even more complicated than attributing CO2 change to temperature change and so on. So I would argue that most climate scientists don't even understand what kind of science is behind this. This is very rigorous, robust, and so on, but there are so many models involved that you can't really explain to people how you did that. So the problem that you're dealing with is essentially that the facts are uncertain, and increasing the knowledge doesn't necessarily reduce uncertainty, and the values are in dispute. It depends on who is dealing with the problem and who wants to change what. So there are not always winners, but there are winners and losers. But the stakes tend to be high. Even if you don't believe this number, even if it's off by 100%, it's still a pretty large number, right? Who's responsible for it? What's the value of life? So the decisions tend to be urgent. So you have to produce information and deliver it to decision makers in a kind of uncomplicated way, in a timely manner, and it has to be usable. That's not always easy. Heavy already showed that, so I won't go into it. The only smart thing Donald Rumsfeld probably ever said. But the human mind, as I said, is always doing risk perception. Whether you're eating dinner and deciding whether it should be low calorie or high calorie, or whether you're going to indulge or not, or whether you're buying a house, a car, whatever, you're always making decisions and you're calculating risk in some way. And for climate models or for climate prediction or for humans, the risk perception can be culture-specific, gender-specific, and so on. And it's usually described in this way, where you have the knowledge producers themselves. For example, if you're a climate modeler, you have a good sense of what the uncertainty is in the information you are giving. And the people who use this information, whether it's a bank or a government or whoever, often tends to take that information and make a decision basically by assuming it's true. So they, in some sense, reduce the uncertainty that's actually in the information that's produced, that the information producers know. But if you're far away from it, like the individual user, they might think the uncertainty is much higher than what is being said by the people who produce the knowledge. So this tends to be called the uncertainty well, or often it's called the value of that, because to get the information from there to there, you have to get past this. And there are lots of examples of how El Nino prediction is used by a bank versus and so on. So this is kind of a schematic, but it seems to work all the time. So when you're communicating anything, you have to remember that you have to get past this value of death to get to human beings. And within that context, we're always trying to say we have to be sustainable, right? There are no real metrics, and sustainability is not a goal that you reach and say, okay, we are sustainable. It's a target. You're always aiming towards sustainability. And what does sustainability mean? The best you can do really is provide kind of a motherhood statement. It's a truism, but how do you implement it, right? It's the ability of one generation to exploit resources without jeopardizing the ability of future generations to exploit the same resources. Makes perfect sense, but how do you convert it into any kind of norms, punishments, regulations, and so on? That's not so easy. So we will keep in mind that I'm going to basically provide a positive message saying that humans are the most cooperative species, and I'll say how they got there or what that means. And that if you look at the long-term evolution, the human society has moved more and more towards cooperation. So even though at a given time it looks like everybody is killing everybody and the world is going to hell in a basket, handbasket, whatever, actually it turns out that in a long time scale we are becoming more cooperative, more global, and so on. So that's where the big history in my title comes from. It was proposed by David Christian, who is a historian, who said, if you want to understand human mind, you have to essentially go all the way back to the Big Bang. So I'll touch on the Big Bang and try to say why that is. And this concept is also kind of being promoted by people like Paul Ehrlich, who's an evolutionary biologist, and Gell-Mann, who's a Nobel laureate in physics. And their idea is that to do this kind of synthesis of Earth system science, sometimes you have to skip the details and kind of take a very broad view and sacrifice depth if necessary to synthesize the information. So I'm going to try to synthesize some aspects of evolution, look at how planet have interacted with evolution, what human beings in the context of evolution, and what that could mean for dealing with global warming, or in this case, modeling human interaction with the environment. Right? So there is always a question of whether humans should be considered external or part of the ecology and so on, but we won't have time to discuss that. So human beings have always been a cooperative species. This is an image of hunting a whale, and there are evolutionary theories as to why human beings became so cooperative. It turns out that if you go back a couple of 100,000 years, as human beings got better and better at building spears and fishing rods and so on, they were basically trying to avoid visual theft. So if you're fishing, somebody can watch you, maybe get better than you and compete with you, or even out-compete you. So it was easier to cooperate and work together than to hide all your talent, because somebody was going to steal it anyway. So I'll keep coming back to that. But they also have been sustainable in terms of being in harmony with their surroundings. So when they were hunter-gatherers, they hunted big game and they shared it because you couldn't really store it for yourself for too long. And this is an image from Hawaii where the tribes had rules on how many fish you could catch. If you caught more than your quota, this is what would happen. So in the modern context, the question is, who decides, who makes the rules, and how do we implement it? And there are lots of examples. Now you see Iran trying to build nuclear power, right? That's what they want. But somebody is going to decide whether they will get it or not. So how do you justify these things? So that's what becomes kind of an issue. So let's start with that. So human beings are basically social animals. We are always dealing with each other from a very young age. We put on uniforms to belong to a group or a team. We put on, color on our faces and so on. So we have a need to belong to a culture, to a group, to a team, and so on. So where does that come from? So let's start just quickly with the Big Bang. Big Bang, how many of you have heard of Big Bang? Is there anyone who's never heard of Big Bang? Never heard of Big Bang? Okay. I would say, how did we spend it? But essentially if you take the